This is SpaceTime Series 25, Episode 127. Coming up on SpaceTime, how black holes control star formation, the last ever Atlas V launch from California, and more Chinese space junk to pollute low Earth orbit. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
New observations using NASA's Webb Space Telescope are showing astronomers how black holes control star formation in galaxies. The findings, reported in the astrophysical journal Letters and on the pre-press physics website archive.org, describe ultra-sensitive mid-infrared observations of the nearby galaxy NGC 7469. NGC 7469 is a Seyfert galaxy with an active centre hosting a supermassive black hole and a ring of star-forming regions. Seyfert galaxies are one of the two largest groups of active galaxies, along with quasars. They have quasar-like nuclei, very luminous, distant and bright sources of electromagnetic radiation with very high surface brightnesses whose spectra reveal strong high ionization emission lines. But unlike quasars, the host galaxies are clearly detectable. The detailed analysis examined the interactions between the supermassive black hole at the centre of this galaxy and the star-forming regions around it. The study's lead author, Vivian Yu from the University of California, Irvine, says the systems, which are seen face-on, turned out to be a real surprise. Yu and colleagues were able to see not just winds from the supermassive black hole blowing in our direction, but also shock heating of the gas produced by those winds very close to the central active galactic nucleus, which is something they hadn't expected to see so clearly. Shock heating happens when wind from a black hole in a galaxy's centre pushes on surrounding dense gas, causing a shock front which deposits energy into the interstellar medium. And that can influence star formation in two opposing ways. Firstly, it can compress gas into molecular clouds, and those clouds could then gravitationally collapse to form new stars. Alternatively, excessively strong feedback processes from the galactic winds could prevent star birth by dissipating molecular gas clouds and destroying stellar nurseries. For decades, astronomers have tried to study the detailed dynamics of Seyfert systems, which make up about 10% of all galaxies. However, dust, which is commonly abundant in the centre of these systems, has made that challenging. And that's where the Webb Space Telescope came in. It gave access to what lies beneath that veil of dust. Using the telescope's 6.5-metre mirror and its advanced suite of tools, the authors were able to measure several key ionised and molecular gas emission lines. These inform astronomers about the conditions of the interstellar medium, the gas, dust and radiation that exist between stars in a galaxy. And that's allowed the authors to pinpoint star-forming regions within a starburst ring. They also detected a high-velocity outflow of ionized gas that's blue-shifted, meaning it's coming towards the observer rather than being red-shifted when it's travelling in the opposite direction. This allowed you and colleagues to see not just what's behind the gas and dust, but also how things are moving at very small scales, something they couldn't previously see at these wavelengths. It's provided a more coherent picture, at least in this system, of how the active galactic nucleus is driving out gas and how that's impacting on the surrounding material. They're seeing definitive signs of the black hole-driven winds dumping energy out into the interstellar medium. Another significant contributor to the rolling dynamics of NGC 7469 is the fact that it's merging with another galaxy. The interaction with the other galaxy means that galactic material is being moved around as a result of gravitational tidal forces. And eventually they'll file towards the centre of the galactic system when angular momentum's lost. The process tends to make the galaxy's centre very dusty, and that's why the Webb Space Telescope was so important for these studies. This is SpaceTime. Still to come, the Euclid spacecraft completes thermal testing prior to its launch, and California witnesses its last ever launch of an Atlas V rocket. All that and more still to come on SpaceTime. The The European Space Agency's new Euclid spacecraft has now completed a key phase of its pre-flight thermal testing program as engineers and scientists continue preparing the probe for next month's launch into orbit. The month-long tests were conducted in a massive thermal vacuum chamber at the Thales Alenia Space Test Facility in Cannes, France. The chamber reproduced the sort of environment and conditions which the spacecraft will have to face once in orbit. Prior to the Russian invasion of Ukraine, Euclid was slated to be launched on a Soyuz ST rocket. However, that job's now being given to the American SpaceX Falcon 9 rocket, which will launch from Cape Canaveral. Euclid will be placed in the 1.5 million kilometre high orbit at the Lagrangian L2 position on the dark side of the Earth. That's the same orbit where the Webb Space Telescope's located in. From this perch, the 2,160 kilogram Euclid spacecraft will use its visible to near-infrared space telescope to study the structure and evolution of the dark universe, searching for signs of dark matter and dark energy, which make up more than 95% of the entire mass energy budget of the universe. The problem is, scientists have no idea what dark matter or dark energy are. That's why they use the term dark. They know these things exist because they can see their effects on the normal matter around them. Dark matter is a mysterious invisible substance which adds additional mass to matter. That results in additional gravity, preventing galaxies from flying apart as they rotate. Dark energy, on the other hand, is causing the cosmic expansion of the universe out from the Big Bang 13.82 billion years ago to accelerate, something it shouldn't be doing. And how much dark energy there is out there in the cosmos will determine the ultimate fate of the universe. Euclid's telescopes will probe the history of the expansion of the universe and the formation of cosmic structures by measuring the redshift of galaxies looking back 10 billion years. And it will see how distant galaxies appear distorted because of gravitational lensing caused by halos of dark matter permeating the cosmos. This report from ESA TV.
Cannes in the south of France. At the Thales Alenia facility, the large thermal vacuum chamber opens, revealing ESA's groundbreaking spacecraft Euclid, designed to observe the dark side of the universe. Euclid is currently in its final phase of testing and has been in this thermal vacuum chamber for about a month to test the functionality of the fully integrated spacecraft under space conditions.
And the point of this test is to take the whole spacecraft and cool it down to its operational temperature and then run it for about a month and check that all the temperatures arrive at the right place where they should be.
The first results of the thermal vacuum campaign are very good. Everyone is very happy and satisfied how it went. Basically, all the subsystems of the telescope work really well under different climatic conditions, and there are basically no showstoppers.
Over the coming weeks, the spacecraft will be subjected to further mechanical, electrical and functional tests at the Cannes facility. After this, the mission should be ready for launch in the summer of 2023 and will be placed into orbit around the second Lagrangian point, approximately 1.5 million kilometres from Earth. From here, Euclid will survey about 1/3 of the sky and will capture data from billions of galaxies, looking back more than 10 billion years in time. In order to do this, Euclid has a payload module comprising a 1.2 metre Korsch telescope with 2 large area focal plane instruments, the visible instrument VIS and a near-infrared spectrometer and photometer called NISP. The instruments will capture the light of distant galaxies from visible to near-infrared wavelengths. With these observations, scientists hope to learn more about the nature of dark matter and dark energy, which together could make up more than 95% of our universe.
So the visible instrument is specifically designed to image over a large area in the visible waveband, and it is making images where we can see the effects of dark matter spatially on galaxies across this wide, large area survey. So we see that the images of the galaxies are distorted, and the distortion is caused by the dark matter in the universe bending the light as it comes towards us. And it's a little bit like when you look through a swimming pool and you see the bottom of the swimming pool, and the bottom of the swimming pool looks distorted, but what you're seeing is the effect of the light being bent by the water in the swimming pool or by the dark matter in the universe.
Similarly, the near-infrared instrument will observe the effect of dark energy by measuring the speed at which galaxies are moving away from us, and hence how the expansion of the universe is accelerating. This is done by observing the shift in wavelength of emitted light, called the redshift of the galaxies.
Cosmology is exciting at the moment. We have dark matter, dark energy. 95% of everything out there we can't really explain. The cosmological models don't quite work, and Euclid is going to hopefully make a huge advancement in our understanding of all of these topics.
Although dark energy is believed to accelerate the expansion of the universe and dark matter to hold cosmic structures together, scientists do not know what dark matter and dark energy actually are. Euclid will dramatically improve our understanding of the structure and evolution of the universe. Euclid is a groundbreaking mission, built and operated under ESA leadership, with Thales Alenia Space being the industrial prime contractor, whereas the telescope was built by Airbus Defence and Space, and the focal plane instruments provided by the nationally funded teams. A Euclid consortium of more than 1,500 scientists will analyse the data produced by the spacecraft. The mission was confirmed in 2012 and is part of ESA's Cosmic Vision programme, enabling astronomers to refine cosmological models and better understand the role of the mysterious dark matter and dark energy.
And in that report from ESA TV, we heard from Alexander Short, ESA's Euclid Mission and Payload Manager, and Magdalena Zafranik, ESA's Euclid Visible and Infrared Instrument Engineer. This is SpaceTime. Still to come, the last ever launch of an Atlas V rocket from California, more Chinese space junk polluting low Earth orbit, and later in the science report, a new study finds that being young, male, religious, and with a high income makes you more likely to gamble on sports. All that and more still to come on SpaceTime. Californians have witnessed a bit of history with the last ever launch of an Atlas V rocket from the Vandenberg Air Force Base. Originally designed as a nuclear missile, the Atlas has been flying since December 1957. It was quickly adapted for manned spaceflight, sending the first American astronauts into orbit as part of the Mercury program. More than 600 Atlas rockets in various configurations have been flown, making it one of America's most successful designs. Its final flight from Vandenberg was for the United Launch Alliance on an Atlas V 401 Centaur rocket, successfully placing the third in a series of polar orbiting weather satellites into orbit for NASA and NOAA, the National Oceanic and Atmospheric Administration. The 2,930-kilogram Joint Polar Satellite System, or JPSS-2 spacecraft, was placed into an 833-kilometre high polar orbit. The probe uses an advanced technology microwave sounder scanning atmospheric moisture and temperature profiles, an ozone mapping and profiler suite which uses 3 hyperspectral instruments to monitor ozone levels, a cross-track infrared sounder used to produce high-resolution 3-dimensional moisture, pressure and temperature profiles, and a visible infrared imaging radiometer suite which takes global observations of the land, ocean and atmosphere at high temporal resolution. The JPSS-2 will be renamed the NOAA-21 once it reaches its final orbit. It'll circle the planet 14 times a day, providing meteorologists with real-time long-range global weather forecasting, including predicting climate phenomena such as El Niño and La Niña weather events. As well as JPSS-2, the mission also included NASA's new Lofted, that is, its low Earth orbit flight test of an inflatable decelerator, which, as the name suggests, is a new inflatable heat shield technology that could one day help land people on Mars. Following the weather satellite's deployment, the lofted heat shield autonomously inflated and re-entered the Earth's atmosphere, splashing down around 900 kilometers off the coast of Hawaii around 2 hours and 10 minutes after launch. Inflatable heat shields, also known as aeroshells, could enable landing heavier payloads on worlds like Mars, Venus, and Saturn's moon Titan, as well as returning large components and samples back to Earth. The thing is, inflatable aeroshells aren't limited by the diameter of the launch vehicle fairing, so they can be made much larger than conventional rigid aeroshells. And larger aeroshells provide more drag, thereby allowing them to slow heavier payloads for atmospheric entry, such as the many tons of equipment which will be required for a manned mission to Mars. And as we said at the top of the story, this launch also marked the last ever flight of an Atlas V rocket from the Vandenberg Space Force Base in California. The United Launch Alliance will now begin redeveloping Vandenberg Space Launch Complex 3 for the new Vulcan Centaur rocket, which will replace both the Atlas V and the Delta IV sometime over the next year or so. For fans of the mighty Atlas ICBM, don't despair, there'll still be Atlas V launches from Cape Canaveral for some time to come. Another Chinese rocket has exploded in orbit. This latest incident involved a Long March 6A rocket carrying the Yunhai 3 spy satellite into orbit from the Taiyuan Satellite Launch Center in Shanxi province. Yunhai 3 is described as a multi-role Earth observation satellite designed to survey atmospheric, marine and space environments and provide data to support disaster prevention and mitigation efforts and carry out scientific experiments. That suggests its true mission involves some sort of surveillance operation. Shortly after the satellite was deployed into its 830-kilometer high sun-synchronous orbit, its Long March 6A launch vehicle mysteriously exploded. The United States Space Force's 18th Space Defense Squadron at Vandenberg says the rocket broke apart into at least 50 trackable pieces in low Earth orbit. Due to its 500-kilometer high altitude, this debris is expected to continue orbiting the Earth for many years, threatening other spacecraft, including the International Space Station. The problem is there's very little atmosphere at that altitude to generate the atmospheric drag needed to cause rapid orbital decay. So the debris cloud will just continue orbiting the Earth, slamming into anything in its way. Think of it as thousands of bullets, all travelling at 28,000 kilometers per hour. This latest mishap follows last week's discovery of space junk wreckage from a Chinese Long March 5B rocket on the islands of the Philippines. That rocket had earlier delivered the final segment of China's new space station into orbit. Beijing deliberately allowed their Long March 5B rockets to crash back to Earth uncontrolled, a practice highly criticized by other nations. The Philippine Space Agency says metal debris was found separately at several locations and was likely segments from the Chinese rocket. Less than 4 hours after the launch of the Yunhai 3 spy satellite, Beijing launched a Long March 7 rocket carrying the Tianzhou 5 cargo ship bound for China's Tiangong or Heavenly Palace space station. The launch from the Wenchang Satellite Launch Center in southern China's Henan province carried some 6,900 kilograms of fresh supplies for the 3 Shenzhou 14 crew members now on station. And China's also launched a powerful new communications satellite into geostationary orbit. The China Sat-19 was launched aboard a Long March 3B rocket from the Jichang Satellite Launch Center in southwestern China. The spacecraft will provide communication services across the Pacific and onto the west coast of North America. The satellite's based on a DFH-4 platform and equipped with a Ka-band high-throughput broadband internet communications payload, as well as both Ku and C-band transponders. China now has an estimated 556 satellites orbiting the Earth, including over 230 Earth observation, surveillance and reconnaissance satellites, including at least 41 Go-Feng and some 107 Yaogang spy satellites. This is SpaceTime. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.